My name is Andy Woodard. Work here at the Capital Factory with ObjectRocket, and we provide MongoDB as a service. Before coming here, I was a SysAd, senior SysAd for a large enterprise-based customers. And one of the projects that I had to work on was setting up MongoDB for a potential new product. And I just put this together to talk about some of the things that I came across while setting up this project and deploying Mongo that hope to make people aware of so they don't have to go through some of the same learning headaches that I had to go through. So one of them was setting up the ulimits, hitting a couple of limitations with Linux that really brought things to a halt. If you're running Mongo on Windows, then this isn't going to be an issue. But running Mongo on Windows is a different issue altogether. I ran into some issues with backups. I was thinking more of a traditional MySQL where you can just dump and do like a zcat of the dump into the database, and you have your data structure back. It works a little bit differently in MongoDB. And Authentication Setup. Set up this huge cluster, everything was great. Decided to set up authentication after I set it up, and then I couldn't figure out why I couldn't get in the database. So, start off with the ulimits. Really simple. It's just basically Mongo tracks each incoming connection with a file, and each internal thread or pthread is a system process, and it also has a file descriptor for each data file. What this means is that some of the default ulimits in Linux, especially for open file handles, is like 1024. And I found that running an API, analyzing statistics, and the poller that I was using to bring data into Mongo, I hit those limits pretty quickly. So
you're saying this is an operating system limit, or not Mongo limit?
Yeah, but it's something to be aware of when you're setting up Mongo. So the recommended ulimits for Linux are to set your open files to 64,000 and your process and threads to 64,000 also. You can go higher, you can go lower. Usually, I found that once I got in the 64,000 range, load tests up to like 20 and 40,000 operations a second really didn't have any issue. So we weren't hitting any of those limits. A lot of the other stuff is set, I think, unlimited by default. We didn't have to change that. That was pretty much that. That was just the easiest part. Doing that resolved a bunch of headaches, and getting New Relic alerts at 3 o'clock in the morning saying that the app is performing weird. So then going into backups, the difference between doing a Mongo dump, Mongo export, I said, hey, okay, I'm just going to export this data because that seems okay. I mean, Mongo dump was there, but I don't really know what the difference is. And Mongo export was cool because it gave me JSON output, and I thought, hey, JSON, it's Mongo, might as well, it works. But that's really for, if you're going to take your data out of Mongo and put it into something like MySQL JSON or something like that, you want to do something completely different with it or move it to another platform, Mongo export is great for that. Put that in JSON and ship it to wherever you need to ship it to, another data store or whatever. Makes it really universal. But for what I was using it for was just standard Mongo dump for data security. I just didn't want to come into a dead server and losing data. So this works great because it gives you just the regular binary export of your data. And the other great thing about it is Mongo can either be running or not. If it's not running, there's actually a flag that you can use where it will go in and read the data files and do a backup of the data from the data files. So I thought that was really cool because that's just made my life a lot easier, especially whenever I can do something like in a replica set. I could take down one of my secondaries. I could back up from the data files and then have my data preserved. So then I thought about, hey, why can't I do, can I do LVM snapshots like we can in MySQL? Because I was like, I want to do point in time, just in case. So I thought, sure, why not? I'm just going to create a snapshot, no big deal. The only problem was that doing some of the tests, I didn't have all the data that I knew was in the database. Just doing a couple of simple queries, my counts were off. And I thought, why am I looking at counts that may be a little bit off? And I still had stuff that was living out in the working set in RAM that had never been journaled to disk yet. So thinking back to LVM snapshots in MySQL, like there's got to be a way that I can do a flush and lock and then do the snapshot and then unlock my tables. And sure enough, there it is. You can fsync lock, take your snapshot, and then make sure that you unlock your collections after you're done. But it functions exactly the same way, which made it super easy. But then I started getting a little bit bigger. And I went from doing a single standalone server like this, which is really easy, taking it back up, not having to worry about it, to working with a replication set where I've got one primary here, and I've got two secondaries. And in that scenario, like I explained, I brought one of these down and just copied data files. It was really easy to do it back up that way. And then I started getting into something like this, where each one of these is a replica set in itself. And now I started thinking to myself, my keynote just crashed? Really? No. I started thinking to myself, how am I going to start backing this up now? Because now instead of having a single replica set where I only have to worry about one set of data, I sharded things out, and now I have data partitioned here. And I may have something that looks like this. I've got usernames that I'm sharding on. And I may have values of that key, A through J living here, J through P living here, P through Z living here. Well, if I want to back this up, how am I going to back up all that data? If I do it this way, I'm going to have 3 different backups. You can use a Mongo dump out here through this MongoOS. This is basically the router that tells Mongo where all this data lives anytime you want to query it. So if you do the dump from here, it will basically read all the data across all of these shards, and it will bring it back out into one single dump. So it's like, cool, that's what I wanted. So good. And then I ran into a situation where I had to migrate from data center to data center, and I was like, oh, I'm going to just do that. 6.5 million documents. That takes for a long, long time. So I started looking up a little bit and found that using data files might be the easier thing to do. So then I went back into my thinking here. I said, okay, well, how am I going to do this? I was able to bring each one of these secondaries out and do a backup of the data that I had living here. And these 3 guys right here, these are where the configuration lives. This basically tells these routing servers where the different parts of the data live. So I said, okay, if I take these, I'll have my data, but am I going to have to set the whole configuration again? Because, I mean, doing that once was cool. I like doing it, and it's a learning experience, but I'm going to do it again, just for migration. So after a little bit of research, found out if I take one of these out, there's no more writes. No writes of the config are going to be done. So I said, okay, that's kind of like locking. I take one of these out, back up the config. Then I can just take all these data files right here that I just copied off and rsync them over to the new servers, and basically brought up Mongo using all of these and brought my cluster right back online. And that was probably the easiest thing that I had to do out of all of the backup scenarios that I had to work with, because it was just a matter of stopping it and rsyncing the data across. And during the maintenance period, I went in and I just changed the app connect string to the new cluster. And as soon as I was ready, I brought it back online, brought the app, just restarted the app, and we were using the new cluster. So I didn't have to worry about losing reads, writes, anything. Of course, I had a little bit of downtime, but whenever you're migrating, a lot of times you're going to have some sort of semblance of downtime. So, but that's covering a couple of considerations. Backing up, like I said, through this routing server is going to give you all your data. You're not going to just be able to rebuild the whole cluster without doing an import, but at least you have the data preserved. And then backing up the individual servers, taking one of the secondaries out is probably the easiest way with no downtime. And then I decided this was a good idea because I just thought that locking down my servers with IP tables I didn't feel comfortable with that. As comfortable as I would if I would set passwords, especially coming from MS SQL, MySQL days of everybody's got a user and you don't do anything with database without a user. So with database, with just going straight into the database, you can create the admin user with authentication turned off. And this is probably the easiest way to do it. Before you actually go in and change the configuration options in Mongo to turn off on, go in and create your admin user, make sure you know what the password is, then turn on the configuration options for authentication, bring Mongo back up, and then now you're forced to authenticate with your admin user. But if you turn on auth and you just connect straight into Mongo from, say, your laptop, you're not going to be able to log in because you can't authenticate. There is something called a localhost exception whenever you turn on auth and you don't have any users yet. So as long as you log in to the actual Mongo server, then you'll be allowed to log in without a user existing, which was pretty helpful too. These are the main types of authentication that Mongo supports. The standard challenge response is just username, password, and authentication database. Really easy, simple. The 509 cert and the Kerberos authentications, I didn't use those, but they were there. We never got to the point where the project was large enough where we had to worry about that. There is also LDAP proxy authentication, but it's only for MongoDB Enterprise, and that's something that is hosted through MongoDB Inc. And I don't believe you have access to doing LDAP outside of that. For clusters, the authentication, going back to the way that we had this set up, there's kind of a quirky way that you have to make sure that you have authentication set up. If you have an admin user set up on your individual shards, and here you have an admin user set up that has a different password, whenever you try and log in here, you're going to be able to log in, but you can't do anything because it's not going to be able to authenticate with these guys. So whenever you're setting up authentication in this sharded environment, you have to make sure that you log into each individual config server, set your admin user, and log into each one of your replica sets in your cluster and set your admin user with the same password. These also use a key file, so they can talk to each other without using a password. Key file has to be the same across the entire cluster, or you're going to get no authentication. I didn't realize that, thinking that these MongoS's are just routing all the commands that I do from here down into the necessary shards. Said, I'm just going to create my admin user up here, and it'll just replicate it across the whole cluster. And it didn't work that way. But once you do have this set up with your admin user, you can create all of your database users for your individual databases across the cluster from here, and everything will be fine. It's perfect. That's what it's made for, because this is just doing the writes of these individual shards. So it's going to write that user to the database that it belongs to and give it database auth. But as far as admin's concerned, they need to be done across all of these guys first. There was. I did have a couple other things with authentication that was kind of a little strange. Whenever you're bringing in these users here, especially now with 2.6, they no longer live at the database level. They all live within the admin database instead of the individual database that they added. They also added huge improvements to the role-based access control. Yeah.
So when you use the word sharding, do you use it as a kind of as like partition, or is it?
Yeah. In Mongo, whenever you shard your data, you're partitioning it. That's why when I use my example, I said like my usernames, I'm storing A through J users and J through P, partitioning the data out so that way I can spread it across.
So what made you choose that it should be through the username and not any other dimension? Like what made you partition or shard on this category?
It depends. It depends on what your data usage is, and depends on what your schema looks like. I mean, it could be anything. I use username as an example because it's easy to demonstrate what the partitioning looks like. But you could have a different field. You could have.
You mean username is a field in your data?
Yeah.
Not users of the database.
No, the actual username key. This could be something like cities. Cities is another one you can use. You basically want to look for something that has a high cardinality, so that way you'll be able to partition and spread across your cluster, and also looking for something that's not monotonically increasing, like a timestamp, especially if you're going to be throwing, every couple of seconds you're going to be adding something new, because then you're just going to end up hotspotting when you're shards, and that's kind of defeats the purpose of why you set it up like this. But it's,
so for time series data, what would you suggest?
So for something with time series, what you could do is if you have a field, basically Mongo now has the ability to do a hashed index, and that allows you to take those monotonically increasing values like time series data and be able to spread it out, because that hash will make it a little bit easier to spread. So, but yeah, as far as authentication in 2.6 goes, they really broke down the roles pretty well. You can give access to users just read, write. You can have somebody who only has access to a database as the user admin. Their whole job is to be able to create and delete modified users, and that's it. So you have that ability. Most of the users, if you just create a straight user without specifying anything, they will get DBadmin, which was the behavior in previous non-2.6, which gives you access to create collections and create users and everything in the database. But the good part about it now is that you can have an authentication database. Say you have foo is your authentication database. That user can authenticate to foo, but have access to bot or baz or any databases that you give them, even if it's just read access. So, but that was a pretty cool change that they made in 2.6. So
quick question.
Yeah.
A while ago you mentioned that if you log into the base server up on top and you don't have a login in bond, the sharded payments, I guess, you won't be able to do anything because you can't log into those unless you create users on those as well. So as soon as you create all your users on all the shards and you log into one of the upper servers, then you're able to, it'll automatically log into the other ones? Or is
so as far as admin credentials go, the admin credentials have to be brought across, have to be added at the individual server level here. You're talking about just adding a database user.
Right.
You'd come in here and you'd add them, and then yes, when that user authenticates through here, they will be authenticated at this layer, which will allow them to be able to perform queries that will be routed down here.
queries and updates?
Yeah, queries, updates. Yeah.
And then once you create the admin user across the 4 different shards there, does that sync if you ever have to change the password for the admin?
Well, you have to go. If you need to change the password for the admin, you have to log into each one and do
all
it.
4.
Yeah. But that right there was the biggest pain point, because I just figured, it's gonna replicate, right? It's gonna be easy, but
Is that something that you know if that's something that's going to be an enhancement later on?
I'm not sure. No. But yeah, that was pretty much everything that I had. Those were the main things that I ran into. Everything else that I ran into there was outside of actually being a SysAdmin. It was actually just running Mongo on day-to-day. But it's hard to cover all those without taking a lot more time than what we'd all have to sit here and talk about. But if anybody has any other questions, you mean ask away. All of them, any of them, anything. Go ahead.
What were the symptoms when you're hitting the ulimit problems?
So what was happening was I would have users that would say that they would do API calls and they wouldn't get anything returned. Or they would get like a 503 error or a 500 error of some sort. Then I go back and check the logs, and right in the logs, Mongo will tell you that they were query set into the open file limit. So that's what made it really easy. I cheated, and I was using MMS for my monitoring, which MongoDB provides. And when you set up your servers in MMS, it will tell you in there for your host that you have low ulimits. So that was how I saw it at first, but I thought, 1024 file handles? Nah, I'm not gonna hit that. No big deal. It's a lot, right? But I underestimated the amount of users that I would have using the test project. So.
What was the threshold or the maximum file handles that you ended up finding out?
I stuck with the recommended 64,000 that they in Mongo's documentation. Probably didn't need to go that high, but figured it's better safe than sorry. So.
What do you monitor to check to see how many are actually hitting it?
Or? No, not really. I mean, realistically, it was one of those things where in order for me to move on to the next piece, I had to resolve that.
Yeah.
As soon as the ulimit resolved it, I went, okay, I'm good, moving on. So, anybody else? Go ahead.
Could you re-explain what you said about threads and p-threads? I'm not familiar with the term p-thread. How that relates to number of users or number of whatever.
So it's more about the number of threads and process threads that are coming into Linux that are being used. And because every time a connection comes through, it's going to open up a new file handle, so and a new process. So that one I can't really tell you. That was, I mean, it's in there in the documentation.
Is that only in the MongoS instance? Because the MongoS instance is the thing that it'll connect to, right?
Right.
And so that thing would have a lot of connections. Those boxes. But do those boxes then delegate and multiplex and gather the data and present it to those connections on the MongoS? The user doesn't actually connect to any of those.
No, the user, they're just gonna, so these MongoS servers basically you could have 100 shards down here. You could have hundreds of servers, and the user's never gonna see that because they're just gonna connect straight into here. So in the case of the sharded environment, I mean, and it really depends on what your MongoS is too, because opening up those process limits, the open file limits on all machines is the best thing to do, because if you end up having 50 of the MongoS servers and you're reaching 20,000 connections to them from the outside, they're going to have to be making connections down to the different shards, and they're going to be spreading those connections out. And they don't just open a single connection. So a lot of modern drivers now, they'll open connection pools. So it won't just be a single query uses or single calls one connection. It could be connection pool can have 15, 20 connections open to the database at one time, and just picking one of those threads to go across to make its request. So
one thing I'd know is that the MongoS is basically a proxy. Think of it like a load balancer you're using for a web server. The analogy works exactly the same way. That's all it's doing. It just is proxying requests back to the backend system. It knows where the data is stored. Otherwise, it's just simple proxy.
But wouldn't it concentrate its queries?
It doesn't have what you would think of as like modern load balancing characteristics. You can't like push connections into one place or another, unless you're doing so by using shard keys. Right? It's a very, very simple process that is just literally forwarding that request back to the shard behind it.
Yeah, with the introduction of tag-based sharding, you can purposefully hotspot one of your shards if you wanted to, because you basically just assign your data this tag and say, for a lot of people will use it for location, and they'll say, okay, if we have East Coast queries, we'll tag it with East Coast, and this is our East Coast data center. So we're going to make sure that those queries that are tagged East Coast get routed to the servers that we have in the East Coast. So you can do something like that, but in general, these configs will hold the data that says where the partitioning is happening and where that data lives. And they're just going to read from there. They don't really know any better other than they're telling them, supplying them the information, and they say, query comes in, it lives here, so I'm going to send it here. So.
Is there a MongoOS for every physical machine, or?
The way that I did the MongoOS, and I've seen recommended a lot of times, is that for every application server that you might have, or every server that needs to make communication to Mongo, it's good to start a MongoOS process. Like, this doesn't have to be its own machine out there. This can piggyback off of something else. So if you're running an API, you can have your API running here in your MongoOS. MongoOS doesn't use any storage, and it's not very expensive. So if you run it here, all of your data is being stored here, and it just caches a copy of that config, which is very small on the server. So the way I did it was I ran my API here, I had my stats app running here, and then my collector for the data was living here, and I just had a MongoOS. So my connection string across the entire, in my code base, was just localhost on the port for Mongo. And this way, if I were to spin up another API server and stick it behind a load balancer, I had another MongoOS. So this way, if for some reason one of my API servers goes down, the other one is still going to have a MongoOS to talk to. So that way I'm not just sticking a bunch of servers up, having one MongoOS, and it goes down, it's my single point of failure. So, and you can make a pool of them, stick them behind a load balancer too, and do that. But this, for me, for the way that I set it up, this was the best way. This is what I felt was going to work the best. So that way, if I ever lost a machine, I still had communication database without losing the MongoOS. So
It's a combination of sharding and replication, kind of.
yeah, in the way, so the way that I drew this up here is these are just replica sets like this, where there's a primary and two secondaries replicating the data around. So this will give you this is essentially 3 copies of your data. And this will replicate all the data from this shard and this one and this one. You can run these with standalone boxes, but realistically, having the replicated data, having multiple servers having your data on it, I think is a lot better than just running the one. But this is the best. This is best practice when running Mongo. If you're gonna set up a sharded cluster, is to have each shard their own replica set. So you can have different or multiple locations that your data lives in. You can also set these up to where you can have another secondary here that's on a delay, and I did this too. I set up one of my secondaries to have a 1-hour delay, so that way I could, if I did anything, especially in testing, sometimes I would make modifications to data that I wasn't necessarily sure was the right thing to do at the time, and then 5 minutes later I realized that I made a huge mistake. So then I can go into this 1-hour delay, which wouldn't get that replicated down to it yet, and I was able to grab that data and replace the stuff that I had in the whole cluster. So, which was very helpful. I've thought of, right before the project got shut down, I had come up with this way that I was going to do something very similar to a transactional, not a transactional, I don't want to say that, but thinking about like T-log backups in MS SQL, where you may do backups of the transaction logs every 15 minutes or every hour or something like that. I thought, well, I can set up a couple of different delayed nodes that I can pull backups from. So I can do a 1 hour, I can do a 4 hour, and I can do an 8 hour. And I can basically take the 8 hour backup, and I'd be able to do a combination of backups here. That would basically mean that at any of these given points in time, I'd be able to do a restore. Very similar to, but not exactly like transaction log backups. I never got to test it, but it was something that I was really hoping that I could put together, because I got a lot of adversity from peers, especially being a Windows admin in previous life. They were like, well, T-logs give us point time, so how do you do that in Mongo? Without transactions, it's a lot more difficult. But I thought that if I was able to, I may not be able to replay the transaction logs exactly the same way, but I might be able to go back and grab data from that point, from a particular point in time, and be able to restore just that data. So that was something that I had started working on but never got off the ground. So
that would be for only one chart or for all the three?
Oh, I had to set up. I only had 2 shards in my setup, but I did. I was planning on doing this for all of them since I have the data partitioned out. I wanted to make sure. In a setup like this, where you only have one replica set and you're not partitioning data, like all your data lives in one group, this would be a lot easier to do and manage. But there was going to be a lot of automation wrapped around that, because I was not going to manually log in and do backups on any of those. So, but that was all going to have to be handwritten, because it's not. There aren't a lot of cool Mongo backup tools automating things right now. So. Well, I will be hanging around the back if anybody wants to come ask me some more questions.